Welcome everyone to Programming for Data Analytics. We are now in the last video of this series, video 18, and the topic of the day is going to be an introduction into Numpy and Pandas. 622, which is the follow-up course, will go more in depth into these two libraries, amongst other things. So today we're really just going to give you an introduction to what they are so that you can go and explore further if that's what you want to do. Otherwise, then, if you're going to be taking 622, then you will kind of get to see how we get to play with those libraries then. So I'm going to start by first talking just what they are and what they're kind of used for primarily, although, they're tools at the end of the day, so you get to choose how you use them and how you don't use them. But I'm going to tell you what some of the popular usages of it are so that it gives you a little bit of motivation as to why you want to use them. So let's start out by talking about Numpy. So Numpy, they're both of these are going to be Python libraries, and I'm actually going to reference the official websites. So let's actually start out by just going to the numpy.org website so you can see what that looks like. So this is the Numpy website, basically, and it does include a lot of really cool things. But the biggest one is that when you're doing so far arrays or lists in Python, you're a little bit limited by what you can do with them without having flexibility when you're going into multi-dimensional arrays. So for example, if you want to make a 3D array or 3D list in Python, I went ahead and I had a video on that, so you can refresh your mind on that. But ultimately, it can get a little tricky and it can get a little complicated because what you're really building is you're building a bunch of one-dimensional arrays and then kind of basically gluing them together, right? So for example, for a 2D, when you're trying to make something two-dimensional, so you got rows and columns, what you're really doing is you're making a list, and then inside of this list are other lists. So you have a list of basically lists, and each of those lists represents a row amongst your data set, right? And so that's kind of what it looks like, really. You have list within list, and it works, and you can use that, and you can use dictionaries, and you can use other things and combinations to make these multi-dimensional data structures, but they're not that fast because at the end of the day, Python is a great programming language to quickly prototype things and to just be able to very quickly write some code. And it works, it's very flexible. There's a lot of nitty-gritty things that we didn't cover in this class that you would see if you were trying to do the same thing in something like C++ or C. And so the reason why all of that is not nitty-gritty is because a lot of things are hidden, a lot of things are simplified for the programmer to be able to write code quicker, but that all comes at a price. And that price is usually in the form of space or time. What do I mean by space or time? I mean, if some information you're reading in would take X amount of storage in something like C or C++, it's going to take a larger amount of storage in the equivalent code for Python. So an integer in C++ will take 4 bytes. An integer in Python, and this is just an exaggeration, it could take something like 24 bytes, okay? And so that may seem very insignificant, but when you start working with large amounts of data, we're talking the difference between gigabytes of data to potentially terabytes of data or something just insanely large in that level. That's the space issue. The time issue is that because this all fancy code makes things so nice and easy to work with, sometimes they're not the most optimized versions of code. So when you're writing an algorithm or when you're writing a program that does something, the Python code makes it so you can write it really short and simple. But behind the scenes, that short and simple code needs to be explained in detail how to achieve it. And not all shapes are going to fit into what you're trying to do. If you think about it suppose you have one shoe. Imagine you could only have one shoe. What would you pick? Well, I would probably pick some general use sneaker, tennis shoe, because that shoe allows me to use it day to day. It also allows some level of usage with sports, but it's not optimized, right? So if I had 10 different shoes to pick from, then I could say, okay, well, let me have a dress shoe for formalities. Let me also have a running shoe for when I want to actually go running, or a jogging shoe, or a basketball shoe. So you would have different shoes that are specialized for different tasks because they're going to give you that edge, right? The same applies with programming. There's a lot of ways that you can solve a problem. And a lot of the times, the way you solve a problem, you try to optimize it to solve it in the best way possible, or you just try to solve it as quickly as possible, even though it might not be the most optimized. And so that's kind of the same thing. So we're going to see an example here where we're going to run a simple for loop, and we're going to do something as simple as a multiplication. And we're going to see that doing it the Python way is going to take a considerably amount of larger time than using something specialized or optimized, which is what we're going to be using with Numpy. And so that's the issue here. Do you want to have one shoe that you just gotta fit one shoe? Once it's working, you are able to use it for whatever you want, or do you want lots of shoes that each one has to be configured separately and organized and decide which one to use? A lot of the times, the best choice is just the one shoe. And then when things are working and now you're really trying to push your limits and try to get as much speed as possible, then you can actually start thinking about using the specialized shoes, or in this case, using a library, or optimizing your code, or changing a programming language and just giving up on Python and writing your code in C. Just as a fun fact, I guess, the most optimized you can get is by going into what this code all converts to, which is assembly code. Assembly code is language that is as close as you can to running instructions in the computer. But that's very, very gruesome. In fact, let me just very quickly pull up on Google some assembly code from x86 so you can see what that looks like. Here we go. Here we got a picture of assembly code. This is assembly code right here. As you can see, we have different instructions that they're doing different things. So when it comes to assembly, I could give you an entire lecture on this. I could give you an entire class. In fact, we have a class like this for computer science students called CS218, which is literally just learning assembly. So I'm not going to do that. I'm just going to tell you really fast that in the assembly world, the way you store information are on registers. And that's the most bare bones, closest to the chip possible. And the registers have names. And so all you got to do is move things into a register, run an operation on that register, move it somewhere else, and then load it to memory, store it in memory, and so on. So like when you see here an instruction that says push to this register, is you're basically moving something there. Or move, I suppose. That's, what is pushing? Either or. When you see something like sub, this is probably a subtraction, and you're subtracting some number from this. This is not the best of assembly codes that I could have found, but all the other, there's no really Google any good examples. But you can see, however, how weird and bad this looks. D words are actually your variable sizes and things like that, and so it's very, very, very not clean. And so no one wants to code in that. If you try to code any assignment from this class, or any class that's not in assembly, you're going to spend a long time. But here's the thing. These are the actual operations that the processor is doing. You could optimize that code the heck out of it so that it's only doing what it needs to do. And most of the time, even when you're writing something in like C, which is pretty low level, you could still push it even further if you go in the assembly code and check it out and remove any unnecessary code. And then you're making it the most optimized possible. A lot of the times, though, it's not worth the time invested to do that. So we're not going to kind of do that. However, on something like Numpy, it's worth trying to do that because you're going to get a large factor of improvement for certain things without having to put as much time as having to learn assembly. Okay? So first of all, how do we install Numpy? The way we install Numpy is we can use our pip. So we can say pip3 install Numpy. In this case, I already had it installed, but I didn't have Pandas, which is the other library that I'm going to talk about today. But all you do is you open up a terminal, you write pip3 or pip install, and then put Numpy or Pandas, and it'll work. So the command is going to be pip or pip3 install Numpy, or in the case of Pandas, then you're with Pandas, as you saw there. And that one I actually did install on this VM right now before I ran the examples. So you can see that you get some code. You may ask a question, yes or no, if you want to install. In this case, I didn't. and then it's going to basically install it. And at the bottom, you should see a message that says successfully installed, and then whatever library you're doing, and it gives you the version as well, so you can keep track of that, because you might run into some issues when you're mixing matching libraries where something may not work with a certain version, so you got to install an older version, etc., etc. So yeah, that's what you'll see. Otherwise, you'll see an error, usually in red, telling you what went wrong. So make sure you read what actually comes out of this. Some of this maybe not very easy to understand, but at least read the end and see the word success, because that is what you want to see, or whatever error you got, and then Google it so that you can see what's wrong. I mean, you can ask people as well, but Google usually will give you the fastest turnaround time. You just Google, see some Stack Overflow people saying the same thing, and find whatever they got their response and try that. And then maybe 5 attempts in, it'll work. Okay, so NumPy. NumPy allows you to make what's called a NumPy array. And these NumPy arrays are super cool because they're very, very optimized. So they allow you to do operations that you would usually do when you're thinking about mathematical operations on things like matrices. So like matrix multiplication, matrix addition. Those are very optimized to be able to run basically quicker, and potentially takes less space sometimes. So let me show you an example of that, because I really want to show you that this will actually be much, much faster than running just a list. So first of all, let's talk about how to make a NumPy array. So if you want to make a NumPy array, go ahead and make a variable. So let's call this variable cool array, I guess. And then you're going to use well, first of all, actually, let me back up a second. Once you've installed the library, how do you use the library? So what you have to do is you have to write the word import and then the library that you want to use. So if you want to use NumPy, you can say import NumPy. However, if you're trying to access any of the classes or functions or variables that are in this library, you need to reference them by using some sort of aliasing. So like, give me the NumPy array, or give me the NumPy var variable, because we may have a var variable locally and we don't want to get confused between those or overwrite them. And so for that, you can go ahead and just say import NumPy and then put as, and then just give it an alias. It's very popular for NumPy to just use the word np, so you'll see that in tons of examples. So we'll go with that. So now once you've imported it, you can actually use all the NumPy tools. If you put an NP there, you'll see a bunch of them here, like literally a bunch of different tools you have. From basic things, here you see, I guess, absolute value. Append, because you're able to append things to NumPy arrays. We got some math operations like, I guess, arc cosine, which is going to, let's see, if we look at the explanation here, it says trigonometric inverse cosine element wise. So it's going to take an array, and I suppose it's going to run what the inverse cosine of each of those elements is, assuming that the array is made up of coordinates on a unit circle. So that's a very, very specific function, basically. Here's another interesting one. So returns the index argmax. So returns the index or indices of the maximum values among an axis. So I guess this is going to help you to find the largest number in that array. Array equal is probably used to compare whether two arrays are equal. True if two arrays have the same shape and elements. Yeah. So shape and elements. Shape is referring to, now we're talking multi-dimensions. So with list, you can always only be one dimension. You can put list within list to sort of make pretend multi-dimensional stuff, but they're really just one-dimensional. Here, you can actually make an array that is multi-dimensional, and what you do is you think of it like a matrix. So when you're building a matrix, enter the matrix here. When you're building a matrix in math, you put your little squares there, and then if it's a two-dimensional matrix, then you have rows and columns essentially. So let's say we have this in our matrix. And somebody asks you like what the shape of this matrix is, what they're asking is what is the length of this and what is the length of this. So this is a 3x4 matrix basically, right? And that's useful to know because when you're doing things like matrix multiplication or matrix addition and subtractions or divisions, you have to have a given shapes for that to work. If you're doing a matrix addition, normally how that works is if you have, let's say, let's make a smaller one so we're not here all day. So let's just say we have the following matrix in here, okay? All different numbers. And I say, go ahead and add this matrix to this matrix. Oh, here, what am I doing? I think this is the identity one. Or I might have flipped it, it might be the other way. But yeah, what if I say add those two matrices together? The way you do that is you're actually gonna add that plus that, and that's gonna go in your result here. And so on. So like this plus this would go here, or this plus this goes here, and then you get where the last one goes, right? So this would be 2, 2 plus 0 is just 2, 3 plus 0 is just 3, and 4 plus 1 is 5. So that's your result. Write some code in Python using lists to do this. Just for now, just think about how you do this. You'd have to have a for loop, and then in that for loop, you would have to do some member-wise comparison, and then run actually 2 for loops because it's a nested version. So it would be something like, or you can just say for I in range. Let's say this is called A and B. This is called C. You can just say for I in range, or for I in A, because that's making a copy, right? Or actually, no, you could actually do that, but you just have to make sure you store the copy somewhere. So here, let's go ahead and say C is our new list, which is going to be like that. And within that list, we can say for I in A, and then for J in B. And now you can say C dot append. We have to make, actually, we have to do we have to make the sublist, right? Because what we have to do is we have to make 2 tiny lists in here for each of the rows. So we can say C dot append, and then just append an empty list. So that's going to run twice and make the 2 sublists that we need inside. And so now here, yeah, we're going to need indices for this to work because we need to put 1 or 0 there. Append, and then just append the value of A plus B. But we know we want to append it to 0 at first and then to 1 later. So let me, oh, here we can use a temporary list. Yeah, then we don't need to worry about indexing. So let me just make a temporary list in here. Temporary list. And then we can say temp.append. And then once this loop finishes, we'll have temp will contain that basically one of the rows. So then we can just say C append temp. And then we don't actually need this at all. Yep, I think that'll work. Yeah, okay. I was just like running it through my head to make sure it runs. So this is cool and all, but it's not efficient in Python because it's going to have to run through a lot of code and load things and load them out and not really run as parallel-wise. It's just sequential and whatnot. But, you know, you can achieve it. This is what this would look like if it was a Numpy array. So assuming you have A is holding the same thing, and A and B are holding the same thing, but they're actually Numpy arrays instead of holding lists. To do C, all you got to do is say C equals A plus B. So from a coding perspective, in this case, you actually write less code. That's super nice. And from an optimization perspective, this will run way faster. So Numpy is a lot like using matrices, and because you're using matrices, you get all the cool properties and all the cool stuff that you, well, cool or also hinders them if you don't remember your linear algebra, but you can get all these really nice operations that you normally do on matrices. So like in 622, when we get to machine learning, we start talking about like regression and all these things. A lot of the times you use a lot of matrices in that to be able to do all the multiplications, and when you get a formula, you get it, you know, with the assumption that you know how to use matrices. So we'll revisit all of this, but you can see that it makes it really nice code with this, and it's going to make it fast. So let me show you the fasting. Okay. So first, like I said, let me show you how to make one of these arrays. So again, the shape is the shape of the matrix. So you know how many rows, how many columns, and whatnot, and also potentially the number of elements that you have in there. You can also initialize it. Oh, sorry for that. Clicked on something by accident. Okay, here we go. So for example, I'm going to make an array, and you can also have, if you have an existing list that you want to convert into an NP array, you can do that. But in this case, I'm just going to make one. So I'm going to make 1, 2. Okay, so I have just created an NP array. Now, what if I want to see what is in that NP array? Can I run it? Can I just say print full array? Let's see what happens. Just like if it was a list. Yes, it does. So you don't need to learn anything new when it comes to printing, because you can just still call the old school. But you know, suppose that we want to make something a little bit more interesting with an NP array. So let's say that we want to put the same data to make that 2 by 2 matrix. So it was a 1, 2, 3, 4. Well, I can put a comma here, and then I can put my 3, 4 here. And guess what? Even the printing is kind of cooler. Field elements. Oh, yeah. Because it's multi-dimensional, I do have to put the outer brackets there. If it was a list in Python, you have to do that. But once you build it into the NP array, you don't need to worry about all this stuff. It's an actual multi-dimensional array. As you can see here, you can print it out, and it's pretty cool. So let's go ahead and put in the other two, or actually just one more. So here, let's rename this now to A and B. And then B had 1001. And now let's go ahead and print out A plus B. Look at that, 2, 2, 3, 5. That's exactly what we got. So how's that? Pretty cool. You can do matrices now. Okay, so that's how you make an NP array. You can also build matrices out of other matrices. So for example, let's make a C that is going to take, so we're going to make a new NP array, and it's going to be made up of A and B. Let's see what happens when we do that. And let's see. Cannot construct the type of array. Oh, I forgot to use append in this. Actually, make an NP array. Oh, hold on. Let's try to do plus. There we go. So we got the same array as before if we add it together. But what if we want to put both arrays together? Check. I think it's concatenate actually. Yeah, it's concatenate, not NP arrays for this. So concatenate. So remember, string concatenation is when you have something like A plus B. So that is actually called concatenation. And so let's go ahead and concatenate them together and see if that runs. Only integer scalar arrays can be converted into scalar arrays. So it's not letting me concatenate them. Okay, let's put this in another set of parentheses. See if it doesn't yell at us. There we go. Okay, it worked. So we'll talk about what vectors and scalars are in 22 for now. But as you can see now, by adding that extra set of parentheses, it now basically glued both of the arrays together by basically taking the first array, which was this one, and taking the second array and sort of adding it. So it's like if you have an array with 2 rows and you're adding 2 extra rows. This is very nice when you're trying to combine data, because if you had to do this without this method, you'd have to make a for loop again and basically run through all the data of one of them appending that, and then have another for loop run through the second array appending all of that as well, and then you'd be done. Whereas here, you can do it with a single line of code, and you get the bonus that this is, again, much, much faster to do. Okay? So let me show you that. Let me actually show you this actually being fast. Like I said, I really want to show you that because you have to see it to believe it kind of thing. So let's go ahead and just make a couple of arrays. Let's do A1, B1, and A2, B2, C1. So here's what I'm thinking of doing. So we're gonna basically we're gonna make a really big list with like, I don't know, 100,000 items in it, okay? Just a bunch of numbers. And then I'm gonna take those two lists and I'm gonna add them together. So I'm gonna do the same thing, but this is gonna be one dimensional. So I'm just gonna add it all together. So it's like I'm making essentially a vector. So there's these matrices that are just like 1D arrays, that just contain data. And I'm going to basically add them together. So that means that my result is basically 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 2 is 5, 4 plus 1 is 5, and I should have one more thing here. 5 plus 1 is 6, okay? So that's what I want to do. Something very simple, and we're going to do it both ways. We're going to do it old school method using a loop and some lists. And then I'm going to do the same thing with NP arrays, and we're going to compare the runtimes to see if I'm lying to you or if really Numpy arrays are going to be amazingly faster. Okay, so for the 2 NP arrays, I'm just going to make them empty. Now, this is not going to be the most efficient way of filling these. There's actually better ways, but I want to keep it simple without showing you more functions. So yeah, this is going to be word store answer. And then we are going to have these 2 NP arrays. So now let's go ahead and populate them. So let's just run again, like I said, a loop with like 100,000. And in that loop, we're not going to time this code. We're just inserting. We're going to append I. So it's just going to append basically numbers there. They're going to be numeric, like in ascending order. But that's again that's irrelevant. For actually adding numbers to an NP array, we are going to use the NP append function. And that is going to require the existing array, which is A2. And then what we want to append, which has to be also an array, which will just be an array with one item. So again, this is not the most efficient way to do this. You could use, I believe, a range could make a better way of doing something like this. But it's okay. Again, we don't care about this. We just care about the addition part. So we got 2 arrays. They have a bunch of data in them. In fact, very quickly, let's see what they have. Okay, so let's do print A2. But for now, let's switch this to just have like 10 items for the quick test here. So you can see that what happened? Module Numpy. Oh, I have one too many R's in here. All right, so we can see there's a bunch of stuff, 0 through 9. Okay, very cool. B2 is going to have the same thing, and if we said A1, we just see a normal list there. Okay. All right, so now let's make this list big. 100, 1,000, 10,000, 100,000. And now let's time some code. So to time the code, we're going to use a time library. So we're going to import time. And then we want to start timing the code when we run the code, when we run a function time. We want to store that number because that's the number of the starting time. That's a Linux epoch time that is right now. And then to end it, or to stop timing it, we're going to save the time again when we finish running the code that we want. So whatever code is here is the code that you're going to time. So this is like, what's the time now? And then like, what's the time now? And then of course, if you want to know what the actual time it took is, we're just going to take the end time and subtract it from the start time. and the end time's going to be bigger, right? Because it's later in the time. So this should give us the number of seconds, to be seconds, I think, that it took to run the code. Okay. So what are we going to put in here? The time is we are just going to do the old school method of how to run this code to do the addition. So 1, 2, 3. So there we go, 100,000. And so we're going to say C1 append the addition of AI. Oh, I forgot for I in range. Times, let's do multiplication. This takes a little bit more processing power. Times B1. Okay? So ultimately, what this is doing is basically saying how long, it takes to run through each of the elements that we have to multiply together. So each of the two that we have to multiply, do the multiplication and store it in our answer array. Okay? And this is just using old school method, no Numpy. Okay? Once it finishes, let's go ahead and print out what the time is. So print to the old school method T1. And then let's go ahead and do the same thing, but using the Numpy arrays, which we've already created, but we're not timing with the creation time there. Okay? So we got the same code. We gotta, again, get the starting time and get the end time, and in between, put the code that we want to test, which in this case is just a single line of code. We're taking A2 and multiplying it times B2. It's like me. Bam, that's all we gotta do. And it'll multiply every single line exactly how we want. Okay, so when we do that, we are going to, actually, is it 1 asterisk or 2 asterisks for the multiplication? Element-wise product, I think should be 1. If we're doing matrix multiplication, I think that would be 2 asterisks, because otherwise matrix multiplication is a different story. You don't, those work different. You have to review your linear algebra for those. But yeah, okay. So now that we have that, let's go ahead and print out Numpy time, and that one's going to be in T2. And then let's go ahead and figure out what the speed up is by saying the speed up is going to be T1 divided by T2, and that's how many times faster it is. If that number is less than 1, it means it actually was slower. If the number is greater than 1, so like if it's 5, it means it's 5 times faster. So that would be amazing, because that's like 5 times faster is like taking 1/5 of the time, right? So how fast do you think it's going to be? I think it's going to be very fast, but we'll find out together. All right, so let's run it, and hopefully it doesn't take too long. So it's running right now. It's probably taking a long time to do the appending part first, because this is not really the way you want to build the Numpy stuff, this stuff up here. We ran into an error. C1 append. Index 2 is out of bounds. Really? Why are you out of bounds? Did we make C1? We did make a C1. And then we're just appending. Weird. Did I put 1 too many zeros here? No. For I in range. I don't know. Let's run it again and see what happens. Maybe it'll fix itself. That's famous last words. But at least let me see the error better. That's a better thing to say. Index 2 for axis. Oh, I see what's wrong. We're saying A and B. A and B are different variables, right? Those are the NP arrays we were playing with earlier. These are called A1 and B1, so that's why you should name your variables better. Okay. This does say A2 and B2, so we won't have issues there. Okay. Let's see how long this takes. It shouldn't take too long. Okay, we're finished. Cool. All right, so again, for the first timing, it took 0.03 seconds. to the old school method, then you're thinking, wow, that's really fast for 100,000 numbers. It's like less than a second. In fact, it's like 30 milliseconds basically, right? Something like that. So you're like, that's pretty good. Like, why do I have to worry about that? Yeah, sure, but like, this is 100,000. What if you're running 1 million or 1 billion? You know, it's going to start to get long, and this is just one operation, right? But still, let's see how fast the NP-array one was. The NP-array one was, move that up a little bit because it is cutting it off. There we go. The NP-array one took 0.0003 of a second. That's a lot smaller in number. In fact, the speed up was 110 times faster. That's about 100 times faster. Now that's fast. Okay? That's fast enough that it's worth doing. If we say that, if we're talking of a speed up of 100 times, it means that if something takes 100 hours in the old school method, it's going to take 1 hour with the Numpy version. Now, which one do you want to wait for? Do you want to wait 3 days? Or do you want to wait while you go to lunch? So, there you go. Numpy arrays are indeed faster. I was not lying to you. However, it will vary. If we run it again, I don't expect us to get the same one. We might get more or less. So let's run it like 2 more times and kind of see what's up. Actually, we could just run it in here and find the average, but yeah. Oh, wow, it went even faster this time. It went 121 times faster. Okay. So far the average is about 110. Because it was 103 and then 120, something like that. Yeah, forgot. Whatever, let's say about 110. 145. Okay. This is going even faster. I think that there's some cache situation going on and why this is speeding up even faster. Because that seems a little suspicious, but it's still ridiculously fast, whether or not that is happening. There we go. 120 now. So it's bouncing. It's kind of bouncing around. It's not just growing every single time faster and faster until we get to like infinitely fast. That would be weird. Cool, but weird. And scary. 118. Okay. So we can see that we're starting, if I run this 100 times, you could save the information and find the average and whatnot. But you can see that at least I can confidently say that it's going to run over 100 times faster, right? Because so far we have not seen a single one. Knock on wood. We're about to see one that's probably less than 100. That'd be funny. So, I was like, it's lower. But yeah, still over 100, right? So at least at this point, after running it with my very in-depth experimentation of about 5 times I ran it, I can confidently say that Numpy arrays are going to be faster for these kind of operations. In fact, potentially over 100 times faster for some applications. Okay, so that's Numpy for you. And that's all I'm going to really cover for today for Numpy, because again, it's going to be something we're going to visit for specific applications in the future. So let's go ahead and move on to talking about Pandas. Okay? So, and I'll leave in the description below documentation, because Numpy does have, both of them actually, Pandas and Numpy have really good documentation with lots of example code on how to use every single function, how to do things, how to not do things, some tutorials, some examples. It has literally an insane amount. And you can also find tons of video online on how to use Numpy and Pandas. So the information is out there for you to get very easily and free. So don't feel like you have to wait to learn this stuff. You can go out there and learn it today. Just like this video is freely available on YouTube for anyone to see. I want to be able to contribute into that pool of knowledge as well. Okay, so Pandas. Let me go ahead and open up the Pandas website so you can see that one. So Pandas is a little bit more of like, there's more things to do with the library, but it's still a really cool library. So it's a little harder to kind of give you specifics of them. But the description says Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the Python program. Install Pandas now. Well, I wouldn't install it this way. I would install it with just pip like I did earlier today. So like this. But yeah, the library, the reason why it just says data analysis and manipulation is because there's a lot of things with pandas that you can do, and it works really well. So here's the thing: NumPy, Matplotlib, and pandas are like a circle of like the Triforce symbol basically. They work together and they do a lot of cool things. So I'm not saying you have to use one for one case and one for the other. It's that they work together pretty good. And in fact, there is a book for pandas, because I know that was mentioned. Somebody was asking that in the live lectures. That even here they're advertising pandas. They're advertising a book. So you guys can check out that book if you want and see if it's any good. And then see. But I ultimately don't know a single source that might be that ideal. So it's just the multiple sources of online tutorials and different videos from different people that work for different applications. Okay. So I'm just going to kind of, for pandas, just give you a quick overview of something we've already done in the past. So in the past, we were doing that COVID data. We did an example of COVID data, and we plotted something with Matplotlib with it and just kind of loaded a CSV file. So I thought I would do the same thing, but using pandas. You can see just how quickly you can get that done. Okay, so I'm going to go ahead and import pandas and Matplotlib. So import panda, plural. And then for pandas, the popular alias is just to use PD. That's what you'll see online usually. Just like with Matplotlib, you'll see that people use PLT. Okay, so for now, I'm going to do something to just make it look prettier that I found on the documentation. So I'm just going to leave that there. Don't worry about that. But yeah, let me show you what the data is, just in case you haven't seen it in a while. So here's the data, as you can see. It's got faculty ID, facility ID, viral load in the water, when the sample was taken, the zip code where the sample is from. I think this one's not really relevant for us, the date. And then we have the difference of what you see there, okay? And the viral loads, I think. So what if we just want to load that in? We know how to do that in with a CSV file. With like just Python and using the import CSV, but let me show you how to read it with pandas CSV sort of reading ability, which is very cool. So we're going to store in the variable called data, and all you say is PD read, and then you are going to say actually read CSV. There's a lot of different reads. So we have for Excel, which is pretty cool. If you need to read Excel files, HTML files, JSON files. Never used the SQL one, but the SQL query one's probably a lot like the CSV if I was to guess. I'm not sure. But yeah, there's a lot of them. What's this HDF? Pandas object. Oh, I see. Okay. So for now, we're going to do the CSV one. Okay. And once we call the function, all we got to pass in. I mean, you can see all the documentation there. But for now, you're just going to pass in the file name. So I believe it's called COVID dry. Okay, and now if I run it, nothing's going to happen. Exciting, at least. Well, it's going to complain to us. Why is it complaining about this? Matplotlib has no attribute. Oh, actually, for the Matplotlib, I forgot. You have to import pyplot like that. So just something you do. Okay, because it's a specific part of the Matplotlib library that we're using. Okay, so that is loaded in. Nothing exciting happens because we're not doing anything with it. But let's go ahead and print it out so we can see it. So I'm going to print out data, and I'm going to just print out the first 3 entries. Now, Pandas is all about data frames, and the data frames is how it stores the data. You can think of it like they're multi-dimensional arrays, basically. It's just what they're called. And so they're really cool. I'm going to show you by printing just this out. Look at that. So it did indeed print out the 3 rows that we wanted. It also prints out, well, actually, is that because I'm printing out the first column? Nope. As you can see, yeah, okay. So regardless of what rows I print out, it actually already recognized that these are actually the column names. And so it's printing them out. So if I want to print out, like, let's say I want to print out the 10th to the 15th item of the list. Well, this is, I guess if it's a 10th item, then this should be a 9 because it starts counting from 0, right? And then this should be 14. But we'll compare that with the Excel file. So you can see there that it's printing out 9 all the way to 13. So let's see if that is actually what we show here. So 9 has a viral load of 7.2 and a facility ID of 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is one. So it's printing out this one actually, which is the 10th one. Yeah, because that's right. Because it's counting from 0. So yeah, it is counting from 0, and by putting 9 here, it's actually printing out the 10th item, which, as you can see, is right there, all the way until what would be the 15th item right here. Okay, which is the 14th item, I guess. So, well, 14th item. Technically the 14th item, but 10, 11, 12, 13. Yeah, oh, I see. 14th. It's just trying to translate indexing from programming to like non-programming history. But yes, it's going from 9 to 13 in terms of indexing. Okay? And so, but you can see the cool thing is that it's printing out all the columns. And if you're using Jupyter Notebook, this formatting looks really smooth. And the columns and the rows, it looks like Excel. It's so nice. So that's nice. But here, let's just stick to printing out just the first 3 elements. So we're going to go ahead and do like that. Okay, so 0, 1, and 2. And that, of course, matches what is currently here as the first 3. And so, yeah, that's just nice all in general because it just read and processed it. So for your projects, I bet you were like, oh, why didn't you show this before? We could have used it. That's fine. That's why you're going to keep working on this in 622 if you take that. Okay? You can go even cooler than this. So, like, because Pandas is so smart, the data frame system, it actually recognizes the column names, so you can actually just print out one column if you like. So like, let's just print out, for example, the viral load column. So I'm going to say print, and I'm going to say data, and then instead of feeding it an index for data, I'm going to feed it the column name. So I'm going to say viral data, like that. And if I run it, what happened? Oh, I know what happened. I think I'm missing a... Oh, I see. It's viral load, not viral data. Right. There we go. You gotta get the column names right. Otherwise, it's like, I have no idea what you're talking about. So there you go. We have name, viral load, length, 5400. Is there 5400 in this? Forgot. Oh yeah, there is. So it's giving you how big the how many entries there are, the type of data, which is float because there's decimals. 64 means that it's using a 64-bit float, which is more accurate than 32-bit float. So just thing. But I mean, Python uses 64 anyways. But what's kind of I like this is cool is that it not only just gives you like the data, like when you say print everything and it's such a massive thing. If you're doing that in Python with a list, it'll just literally just print out every single item, like nonstop, and it'll just flood your terminal, and you're like, oh, damn, that's annoying. Pandas is more cool about that. It's like, yeah, okay, this person's trying to print out 5,000 rows at once. He probably didn't mean to do that. So it prints out the first couple of rows, puts 3 dots, and then prints out the last couple of rows. How cool is that? So you get to see like the data and you get to see the beginning and the end. And you're like, oh, cool, okay. You know, you're writing code, you're like, I want to see what this data looks like. You don't need to worry about like, oh, I should only print out the first 3 rows or something. No, it just assumes you want to do that. Now, of course, if you actually intended to print everything, you want to make sure this doesn't happen, right? So you would do it a different way when we talk about that. But normally, if you're just trying to analyze this, and this is pretty cool because it's a nice way to do that. And that's actually the same thing that happened here with when you're printing out the whole data thing that we did here. It actually cut a couple of the columns there, and technically it only cut I think it only cut like the third column. It cut out sample date, write zip in there because there was too many. So again, it's just trying to give you some nice output because it assumes that you're working on this and you don't want to spam your terminal with information. But yeah, you're able to print out all that stuff. Now, of course, if you from this, you just want to print out, again, just a sub set of those. I think if you do that, it'll be okay. There we go. So we just printed 3. And in this case, because it's so small, it'll give you all of them as well. Okay, so that's how you print out the data. The last thing is, let's go and plot the data. Let's see if we can do that. So we're going to plot the viral load data. Because I think we did that the other day. So viral load, and then we're going to call plot. This is where your matplotlib is going to come into play. So it's using the same thing as before. If you plot it, as we saw last time, you actually don't get to see anything interesting. So you have to use plt show to actually see it. And there we go. This is the viral data. And the labels are just by amount of entries. It's just kind of splitting it in terms of amount. So it's not using the date. For that, you have to modify the X and Y axis. And I'm not sure why these are going to 0. Oh, I guess there was nothing on the viral load that day. But you can kind of see it. It's just a wave, I guess. So yeah, that's pretty much it. So now you have seen how nice and quickly it is to do on Pandas, to be able to load some data, look at it, look at a subset, potentially graph a piece of data. And of course, you can do a lot more things to this. You can start doing some analytics on this, or some math, convert, manipulate the data as you want and see fit, and you're good to go. So yeah, okay. That's really all I wanted to show you. A quick introduction into Pandas and Numpy to get you excited and to maybe get you curious about it, so that then you can go in and play with it on your own time. And then, if you take 622, then you'll get to see it a lot more as we use it through different tools and different things that we do with it. But for now, this is the last video of the 621 set. So I'd like to thank you all for your time. I hope that you got some good knowledge out of this and that you can take this and use it for your projects. And remember, programming is supposed to make your life easier, not hard. So make sure that's the case. And if that's the case, then I think that we've done a good job together. So with that, I leave you. Thank you all, and I'll see you all in 622.